As we're working through the steps of dividing rational expressions, you'll see that we follow the same procedure that we've seen already. And that is, we take the second fraction, we flip it, or find the reciprocal, and then we do multiplication instead. So just to refresh your memory, I have a division of two fractions over here on the left, 2 over 3 divided by 5 over 7. Remember that if we were to divide these fractions, we'd write down our first fraction just as it is, we'd change our division sign to a multiplication sign, and then we write down the reciprocal of our second fraction, which is 7 over 5. So we've changed our division question into a multiplication question instead. And then we go through and do our multiplication 2 times 7 and 3 times 5. So this procedure that we do with fractions is the exact same procedure that we do with our rational expressions. Here we would copy down our first fraction just as it is. We change our division sign to a multiplication sign. And then we flip our second fraction, that is, we take the reciprocal of it. And now we work through this multiplication instead. 3 times x minus 3. And x plus 2 times x minus 1. Just like we did for multiplying rational expressions, make sure that if you're dividing two larger rational expressions, that you factor first. Not only will factoring first allow you to cancel out any common factors as you move through the multiplication step, but you also need to use your fully factored form to write down all of the restrictions before we cancel out any of our common factors inside of that multiplication step. Okay, let's work through a couple examples of dividing rational expressions so you can see the procedure of what to do. What I tend to do first is factor everything, get everything in fully factored form, and then worry about first finding the reciprocal of the second fraction, second stating your restrictions, and then lastly simplifying everything. So I'm going to begin with this fraction and try to fully factor it. So in our numerator we can factor out 14 and we're left with 2x minus 1. In the denominator, let's pull out a factor of 15 and we'll have 3x minus 2. In our second fraction, we can take out a factor of 7, so we'll have 2x minus 1. And then in the denominator, we can take out a factor of 10, and we'll have 3x minus 2. So let's go ahead now and take the reciprocal of our second fraction. I'm also going to change our sign from division to a very sloppy multiplication sign. Sure, that looks great. Okay, so 10, 3x minus 2. Now, our restrictions for division questions are a lot more challenging to think about. What we're not allowed to have is we're not allowed to have either original denominator equal to 0. So that means that this 3x minus 2 is not allowed to be 0. So let's begin with that one. We could add 2 to both sides, and then divide both sides by the value of 3. So we see that x is not allowed to be 2 over 3. The other restriction we have is this 14x plus 7 is also not allowed to be 0. If it was, then this fraction would be divided by 0. So that tells us that 2x minus 1 is also not allowed to be 0. We should get a value of 1/2. So what I'm going to do is I'm going to put stars beside all of the places you have to check for restrictions when we're working through division questions. You need to make sure you check both of the denominators of your original fractions, as well as the numerator of the second fraction. Let's return our focus back down to our multiplication. So here we can go ahead and cancel out our common factors. It looks like 2x minus 1, those factors will cancel. Our 3x minus 2's are going to cancel. And we do have a factor of 7 that will go into 14 2 times. And we have some factors of 5 that we can cancel off as well. So I'm going to get rid of a factor of 5 down here and a factor of 5 up here. And we can go ahead and multiply 2 times 1 times 2 times 1 to get our final value of 4 in the numerator, and then 3 times 1 times 1 times 1 to get our final value of 3 in the denominator. Moving on to example 2, let's work through fully factoring our rational expressions first. So working with our first fraction, our numerator is already fully factored, so we don't have to do anything with it. We just have to factor our denominator. So we look for two numbers that multiply to give us negative 10 and add to give us negative 3. I'm assuming that 5 and 2 are going to work here. We just have to figure out our signs. So if we start with negative 5x and add 2x to that, we'll get negative 3. And we go on to our second rational expression, again only factoring the denominator. So we need two numbers that add to minus 1 and multiply to negative 20. Those numbers are going to be 5 and 4, and we need minus 5x plus 4x. Now, from here, let's take a look at what our restrictions are going to be. Remember that we need to consider both of our denominators, as well as the numerator of the second fraction. So the denominators are going to give us x cannot equal to 5, negative 2, and negative 4. The numerator of the second rational expression is going to give us x cannot equal to 0, and y cannot equal to 0. So those are our 5 restrictions listed up at the top. Now that we have our restrictions done, let's go ahead and flip our second fraction so that we can multiply. And from here we can look to see if we have any common factors, which we do. We have x minus 5 and then x minus 5 that we can cancel off. We have 3 factors of x in the numerator and 1 factor of x in the denominator. So I'm going to get rid of one of those factors of x to leave us with an x squared in the numerator. We have 2 factors of y in the numerator and 4 factors of y in the denominator. So I can get rid of 2 factors of y in the numerator and 2 factors of y in the denominator, and that'll leave us with y squared in the denominator. So our last step is just to multiply everything together, and we'll end up with x squared times x plus 4 in the numerator, and we have y squared times x plus 2 in our denominator. Let's work through one final example of division. I'm going to begin by trying to factor our first rational expression. Now I'm going to do some side work in blue down at the bottom because this is a more complicated quadratic expression for us to factor. Now I'm going to use the technique of trial factors. I'm going to look at the number 6 and I'm going to write down the different factors of 6. And then our last number is also 6 and I'm going to write down once more the different factors of 6. Now remember that we need to match them up in such a way that our middle term is 13. Now it turns out the pairing that we need is 2, 3 and 2, 3. Specifically, we need 3 times 3 is 9, plus 2 times 2 is 4, for an overall value of 13. So this means we're going to factor in the following way. We need our 3n times 3 to give us 9n, and our 2n times 2 to give us 4 more n for 13 altogether. The denominator of our first fraction, 4n squared minus 9, is a difference of squares, so we can factor this one as 2n plus 3 and 2n minus 3. Moving on to our second fraction, I'm going to again write down our factors and try to use trial factors to figure out how we're going to factor this particular quadratic expression. So for 6, we know we have 1, 6, 2, and 3. And for negative 2, we're going to have negative 1 and 2, or 1 and negative 2. In this case, it looks like we're going to use the following matchup. We need 2 and 2 for 4, negative 1 and 3 for negative 3, and when we add those together, we'll get positive 1. So here's what we get when we factor the numerator of our second expression and the denominator of our expression 4n squared minus 1. Again, this is a difference of squares, so let's go ahead and break this up into 2n plus 1 and 2n minus 1. Now, of course, this is still a division question, so it looks like I've accidentally put a multiplication sign in between our two fractions, so if you could just change that to a division sign here. I'm also going to go ahead and erase all of the work I've done in blue at the bottom in preparation for flipping our second fraction. Now, if you do want a little bit of an extra challenge, I am going to put in a couple of stars here to remind you which factors we need to look at when working with our restrictions. So after we're finished the question, I'll post up all of the restrictions in the upper right-hand corner. My recommendation is to give it a try, see if you can find all of the restrictions for this particular question. I'm not going to do that. I'm going to focus on working through the multiplication and canceling off our factors. But like I said, I will put up the answer if you want to double check and make sure you can find all of those restrictions at the very end. So here's what our question looks like after we take our second fraction and we take the reciprocal of it. Now we can work through the cancellation stage to see if there are any factors that are going to cancel off. And it looks like we do have a couple, so our 2n minus 1s will cancel. We have 3n plus 2s that are going to cancel. And we also have 2n plus 3s that are going to cancel. After all of our cancellations, in the numerator we're left with 2n plus 1, and in our denominator we're left with 2n minus 3. So if you have gone through the trouble of trying to check all of your restrictions, here is the final list up here. Alright, my little epsilons, stay positive.